Anyways, I'm going to talk about some of these slides you all have seen in past GPSLs, but since we have a lot of newcomers, I'll go through them quickly. And just I wanted to talk about the difference between regular high altitude ballooning with latex weather balloons and Pico balloons, which and kind of the differences between the two, and then I'll get into some of the hardware. So you'll see right behind me in my background, that's my balloon I'm going to fly on tomorrow. I've already pre-inflated it to the proper lift, and it's now my background. That's a 36-inch Mylar foil balloon from Qualitex, which is the one that seems to work the best. Did the slide update okay?
Yeah, you're good.
All right. So this is a typical latex balloon. Most of you are quite familiar with this, although the nichrome cut down, I don't know if a lot of people use that, but we did that on some flights with the university just to prevent the balloon from getting all tangled up. We had a little UHF receiver and a little microcontroller that detected a code, and we would transmit from the main payload box the cut down command, and after it achieved a certain altitude, or we sent an uplink command via packet, and then it would send a little RF signal up to the receiver in the nichrome box and cut the balloon loose. Actually worked pretty well, and the box was light enough. It had a couple lithium batteries in it, a little nichrome wire, and it would flop around and wouldn't affect the parachute too much. It kind of spun around above the parachute. So that's just an overview of now your balloon's going to cost you over $100 probably, and nowadays with the cost of helium, you've got over 100 cubic foot of helium, so your expendables in the balloon are probably $200, $300 nowadays to do a flight like this. Of course, we had a big program at University of Alabama, Huntsville, and we were doing, as part of their senior design course, we were doing student flights. We'd do 5 a semester, and we kind of let them go wild with their payload design. That is a functional payload, and the eyes would actually light up. And I can imagine if you were a farmer finding this in your field and the thing's lighting up, just what kind of reaction they would get. They'd probably run screaming away. But we had a lot of fun with these flights. Unfortunately, the new administration decided that engineers design and technicians build, so their hands-on classes are fewer and farther between, and they did away with the balloon sat program. But we launched 65 flights over the course of 10 semesters, which was a great program, and we had a big chase team and a large involvement with the ham radio community and Huntsville here. We've flown all kinds of stuff. Somebody asked about a crossband or a voice repeater in the sky on the GPSL list the other day. This is as simple as it gets. That's a little Radio Shack simplex repeater. Argent Data sells one that works really well because you can't buy the Radio Shack simplex repeaters anymore, but it listens for 20 seconds, transmits for 20 seconds, and you've got yourself a repeater in the sky. You can talk hundreds of miles over a 12-state area in this region. Chase and recovery vehicles, that's part of the fun. In fact, a lot of people, that is their fun. They just love the chase and recovery. And I hope this guy lowers his elevation down. That's a Azel GR 5600 Yaesu full up on top of this guy's car. And I hope he lowers it before when it goes under overpasses. It could be a bad day. And those are aero antennas, which work pretty well, and they all disassemble, so it's easy to take it apart. You may have remembered this photo from a few GPSLs ago, the one we did in St. Louis, but and thanks to Jeff Ducklow and KD4STH and KD0QCA for their balloon payload. Well, actually, Jeff Ducklow took this picture at 53,000 feet from 200 feet away. If we tried to do this as a government project, it would cost $1 million and it would fail, and they'd have to add another $1 million to try and make it happen. So, but this is just phenomenal. We got the lift just perfect, and they followed each other throughout the end of their flight, and I think they landed maybe a block away from each other. But that's a real cool example of what a latex balloon looks like as it enters into the stratosphere. And you see that thin blue haze, that is the Earth's atmosphere, and the black above it is the blackness of space, and we're going into the stratosphere, even at 53,000 feet. Of course, this is about 85,000 feet, and this is the view over northern Alabama. We had an experiment at a science camp in Indiana, and we asked them what they wanted to see flown, and angry birds in space was the big game at the time, so we flew an angry bird, and it was a very angry bird. So we flew angry birds in near space. So in latex balloons, they pop, they parachute and come back down. And of course, this always happens, right? It lands right next to a parking lot, next to an open field, and you walk right out, pick it up, and off you go. Easy peasy. Of course, this never happens, rarely happens. This happened at GPSL in Hutchinson. This is what usually happens. High up in a tree, horses eating it, cows eating it, or on top of a building. So I wanted to show you some of the impetus for what really caused the wireless age. I bought these at a Hamfest, and I tried to make them a stereo system, but you get a lot of exercise. It's eco-friendly, doesn't use any power, but it's difficult to keep them in phase. Now, as we're approaching hurricane season, we might get a Cat 5 storm, and I wanted to show you what a Cat 5 storm really looks like. And Mike, being an IT, you're going to enjoy this. That is the Cat 5 storm.
I've seen that.
I've seen that all too often. So this is like the inspiration for going wireless and ham radio and digital modes. So I'm going to talk about now the difference in long duration Pico flights is instead of paying about $200-300 for your balloon and your lifting gas, now the balloon is about $4 and takes about a cubic foot of helium or hydrogen, or that, whatever they call it, the 80% balloon time helium. So that's a little difference. Now the expenses in your payload, which you're likely not going to get back. Although I have gotten some back. I put my email address on the bottom of the solar panels, and I've gotten a number of them back. Sometimes weeks or months later, but people do find them. So instead of lugging a 200 to 300 cubic foot tank of helium that weighs over 150 pounds, this is easily carried by one person, and that's a 40-foot cubic tank of hydrogen. You can also get it helium. I got that in my local welding supply shop, a little mom and pop shop. If you walk into Airgas and you don't have a commercial account with them, and you'd say, I want a tank of hydrogen, they'll probably laugh at you. And then they'll really laugh if you say, I want helium. So I just go to the local welding supply shops, and they're pretty accommodating. So they sold me this for like, I don't know, 20 bucks for the hydrogen and $10 a month rental if I keep the tank longer than a month. So really handy. You're only using, you can get upwards of 20 or 30 flights on a Pico flight out of one of these tanks, and you can lug these anywhere. They're not much heavier than those balloon time tanks. So in the world of Pico ballooning, the idea is to keep your payloads as lightweight as possible, preferably under a half an ounce. So these are all some of the Pico balloons that have been designed. The payloads, mostly APRS, some are Whisper. Mike, there's your latest WISP-2 on the bottom left-hand corner. SB9 UAV, his latest one I just saw yesterday. I didn't update it, but he's about 2 or 3 grams on his. He's in Poland, and he's done some really innovative stuff. And KT5TK, it's flown a lot with the Southern Texas Balloon Group. and W7QO. Leo M0XER was one of the real pioneers in Pico ballooning and getting the very lightweight payloads. And Andy VK3 YT in Australia, he's got a couple of flights going right now around the world in the Southern Hemisphere. QRP Labs, he's working on a U4B that VE3KCL is flying, and I'm not sure when he's going to release it, but I think it's about half the size of this U3B board. So there's a couple of those flying right now that Dave up in Canada has been flying for him, doing test flights. Now KD2, KDD, and KN4 IUD, they came up with this version for Whisper payloads. And then the QRP Lab sells the Light APRS, and DB1 NTO sells the Pico APRS Light. And on the left is Eduard from Romania, YO3 ICT. He's come up with a tracker that weighs just a couple of grams on Whisper. And I put them together. We did one for the W5 KUV flights that I'll show in a little bit. And they're 0402 surface mount, big magnification, steady hand, and I'll show you one thing that has come in handy for working on really small stuff like this. So I designed a board called the Skytracker, uses U-blocks, right? I use the 7Q or the 8Q. It's the Max series, that little white chip on the left. I'm going to try something here. Mike, where is that? How do I get into that highlight thing, the laser printer? Do you know?
It's if you get into your options where you have share screen and mute and unmute and all that, to the right of share screen 1 or 2, there should be an annotate button.
I don't see that because I'm running full screen. Oh, there we go, annotate. So let's try. Yeah, there it is. How's that? Can you see that?
Yep.
It's a high-tech laser pointer. So this is a GPS antenna. Some people use a wire, about 2-inch wire, but these are fairly cheap and they work pretty well. That's the Max U blocks. That's an Atmel 328P, the same as used on the earlier Arduinos. A to D converter. That's a parallelity to A to D because it was to generate the 1200 and 2200 hertz tones for APRS. You want to have a fast A to D DDA converter, and then I run that into a reference oscillator on 16 megahertz, and it's a VCXO. So the audio from the APRS tones does a direct FM modulation of the Cypress synthesizer. And that's an output filter and voltage regulator. So I also wanted to point out, see those 6 pads in the upper left-hand corner I'm circling, and there's 3 guide holes. I used a thing called Tag-Connect, which is a Pogo plug adapter to my programmer. I used an STK500 programmer for the Atmel chips. And this allows me not to have the weight of a header, 6-pin header on the board, which saves a lot of weight, and it's real convenient. You just push the Pogo plug on, program it, and off you go. And they have a little clip underneath that can hold it in place if you're doing a long-term programming effort. But keep track of those clips because I've ordered so many of them because I keep losing them. Okay, now I guess I had to get out of annotate to advance the slide. So I use a Murata SuperCap. It's 5.5 volts, half a farad. Unfortunately, they discontinued it, but I have the world's largest supply of them now. So they weigh 0.8 grams. The cylinder cells, you'll be up around 2 or 3 grams to get the voltage that you need. So these are real handy. They're flat packs and they're very lightweight. So I use these on the board. You have to put balancing resistors on them, however, because you have to keep the 2 cells within that pack balanced. So I have 16K resistors between the legs. Now, what happens if you put 9 volts on a 5.5 volt max super cap? You let the smoke out. I put a battery pack on this through my test connector, and I had a 9 volt battery laying around, so I hooked that up to it, and I walked away, and it says, "Oh no, that thing's only rated at 5 volts." And I ran back. Before I could get to it, it went kabang. Sounded like a firecracker. So don't do that to your super caps. It put carbon everywhere. So this is the board. I get them made from JLC PCB in China. They're 1/3 the normal thickness. And my new Whisper board, which should have done this next week, I'm going to send it out to the board house. It will be approximately half that size, but it'll be Whisper only. Now here's some useful test hardware. There's a video microscope that I got on Amazon, Androstar it's called. It's got really neat high intensity lamps. You see that tiny tracker down there in the spotlight, and that just displays a really cool high magnification view of your solder joints and your text. So you're working on really small boards like that YO3 ICP tracker. This was really handy, and I think I paid about $140 for this, and it's been a valuable asset to my workbench. If you're doing antenna analyzing for optimizing HF antennas, magnet wire antennas, or even 2-meter whips antennas, I found this antenna analyzer that do HF, VHF, and UHF, 0.1 to 1.3 gigs. It's called the Mini 1300, and I got this on Amazon or eBay. They're $200 from eBay, and if you can't wait to get it in a month from China, then they're about $300 from Amazon. One cool feature. Yeah, go ahead.
Going back, when you're done with the discussion of the antenna analyzer, we had a question in the chat from Derek about what the header on the back of your board is for.
Oh, the header is a test power connector. So I can, when I power it up on the lab bench, I put a little JST connector on it to a 4.5 volt power supply or a battery pack. And that way I don't have to be outside. Since the board is totally solar powered, that allows me to test it on a lab bench supply or a battery pack. So the Mini 1300 also has a neat mode that if you're just setting up Whisper, FT8, or FT4 or JT65 for the first time, you can have it do a test generation of Whisper, and you can enter your details. You see my call sign, grid square, and the power level, and it'll do a beautiful, you can put it on the air even, it puts out 10 milliwatts. And I put this on the air, and there's no GPS to sync it, so you have to get the start time just right. But you got to be within about 2 to 5 seconds on your start time. But I had reports all over the country on this. So this is that tag connect pogo pin connector I was showing you. And it has a standard DIN connector on the other end on the ribbon cable to plug into your programmer. This is the full-blown Skytracker with power film solar cells. Those are the MPT 3.6 volt, 75 milliamp panels. So I get about 150 milliamp power capability at full sun. And of course, the board only draws about 35 milliamps at 3.3 volts. So they're way overkill, so I can get a lower sun angle combined with the super cap on the back. I can get down to about 15 degrees solar elevation, 13 to 15 degrees, you know, when the sun gets low. So it's a ideal STEM student experiment because it's a single hand launch, takes the balloons $4 and takes a cubic foot of lifting gas. And I've launched these in 20 knot winds, but if you do, make sure you have about 1,000-foot clearance. I was on an airport runway in a small airport, and the winds was right down the runway, and it took all of 1,000 feet at 25 knots to get past the tree line. But if you're down around under 10 knots, 5 or 10 knots, a football field length is probably good. If it's a calm day, then it'll go straight up. So one-handed launch, even in a moderate wind. So one thing you have to worry about with APRS Pico balloons that go around the world is APRS is different frequencies on different parts of the world. We're 144.39 for our APRS network. Europe, Russia, and there really aren't those stations in Africa shown, just South Africa and a few smattering in Morocco and the Canary Islands. The rest of it is really not there, but that's 144.8. And then China, Korea, and Japan are 144.62, 64, and 66. Why they couldn't just say, let's all go to 64, I don't know. So I have to change frequency. I draw a geofencing box around each area, and I switch the frequency to the local frequency as I fly into that area. I also have to be concerned about the UK, Yemen, and North Korea. I can't transmit over those areas, as Stephen pointed out earlier. The UK does not allow amateur radio aerial operations. And you'll see there's KD0VJI-11 flying one of my boards, and right as it hit the box, it stopped transmitting. So that was my first real world example showing that it actually worked. And thanks to Mike and Alan, W7 QO, and for your integer-based point and polygon geofencing routine, because it works great, doesn't take up much room on a small microcontroller, and it really makes geofencing work well. So between, I use the geofencing algorithm for changing frequency and to make sure we don't transmit. And here's another real world reason you want to have a geofencing algorithm on your tracker. KK6UUQ-9 just recently flew across right directly over Pyongyang in North Korea. And you'll note there's no red dots over Pyongyang or North Korea. It stopped right where it was supposed to, and it started up on the other side of the box. So it does work, and thank you, Mike, for that integer-based algorithm. So my first Pico flight went 27,000 feet. So it was kind of heavy, and I was using the balloon time gas, and it ended up off the coast of Sweden in 6 days' time. We launched one for W5KUB with W5KUB Tom in Memphis, and it arrived in Japan. And the really neat thing, this is that tracker.habhub.org that Steve Randall showed earlier. There's the URL, tracker.habhub.org, and it's really geared for high altitude balloons. But if you send a text message to the UK Haas IRC channel or the HabHub channel and ask them to put a high split button on your flight, and you click that, it will show you predicted flight path out to a few days out, and gives you a couple scenarios of where it could possibly go. And this is a real handy tool. I do it by hand, which is time consuming on the NOAA site, NOAA High Split. But to have this feature on the HabHub site is really useful. So, and thanks to everybody at the UK Haas group. I don't know if any of them are still on, but this is real handy. So we do a number of school events. That's Bev, WB4 ELK. She just recently got her extra class, and she did her tech license, and just 2 months later, she went and got her extra. And she's helped me on a lot of flights, and she managed to get the vanity call WB4 ELK. So I don't think it's a herd of elk. I think it's called a gang. So we're a gang of elk. And the kids love it. They think it's a space launch, and we had the entire 6th grade class out there watching this. Of course, this was before This was a year ago before all this virus thing popped up. And they tracked it on their smartphone. If you get the kids involved with their smartphones and say that you can track balloons or do science on your smartphone, you got them hooked. Otherwise, they'll get bored easily. But if you get their smartphones involved or their iPads and show them that they can track things every day, they will really get hooked. And their middle school flight made it all the way to Morocco. We do flights at the Hamvention. I'll post a link of the race for, I showed this last year, but I'll post it for those that haven't seen it before. This is the hex beam at the Dayton Hamvention. And of course, it acted like a spider web for our Pico balloon we launched at the Dayton Hamvention. And they shook it around, moved it up and down, and it finally fell off. Then it hit a power line. Then it stayed in the power line 5 minutes. It got off of that, hit a thunderstorm, almost knocked to the ground. And then it finally made it past the thunderstorm and went to Turkey in 10 days time, 11 days. So that was the little balloon that could. So I want to talk a little bit about different modes other than APRS, weak signal modes that people have used in balloons. I did this on a balloon with Feldhellschreiber. Great visual mode. You got to get the timing right or it slants on you. So, but I had a blast with this. People had a great time. The only difficulty is your eyes actually do the filtering of the noise level. So it can be a weak signal, but you can still read it with your eyes. It's a wonderful mode. It's not that hard to implement. It's just on-off keying at a particular rate to create the letters. And I did this during a long duration latex floater many years ago. A lot of group are using Contestia in Europe. SB9 UAB flew basically right over my house after going around the world, and I copied this right off of my screen. This is on 434 megahertz, and I'm using DLFL Digi, as Stephen pointed out. And this goes directly, uploads directly to the HabHub servers, Habitat server, to show up on tracker.habhub.org. I haven't tried to implement Contestia, but I know several in Europe have done so quite successfully. And this is an example. I actually tuned into a remote SDR in Arizona, a web SDR, and looped the audio from the website into DLFL Digi and decoded it all the way from Arizona on 434 megahertz. So it can be done. JT9, Edward, YO3 ICT, has a JT9 mode on his. I have the option of doing it on my Whisper Skytracker, but I never really have implemented it. But VK3YT used it as a primary mode on one of his balloon flights, and I could copy it all the way from Africa when he entered Africa, all the way from here in Alabama. And I think he's running about 10 milliwatts on 20 meters. So some of the modes, CW, that's fairly easy to implement. I use it sometimes on a latex flight. I can configure my Skytracker as a latex balloon tracker with a battery pack. I put 4 AA cell lithiums on it, and it'll run 36 hours as a backup APRS tracker. And I also can output teletype or CW of the position when it's on the ground, in case you can't quite decode it on APRS. Domino EX, love it. I've had several flights with Domino EX. However, none of them will upload what people receive like APRS does, except for Whisper. There's a website called whispernet.org, and the free Whisper WSJT-X or Whisper programs will upload whatever they receive to a central database, and I wrote a Python script to grab that data, decode it, convert it to APRS, and send it to the APRS servers just like it was an APRS balloon. You'll see the coverage range on over the horizon Whisper. I'm running 20 milliwatts on 20 meters to a 3-gram magnet wire antenna, 17 feet up and 17 feet down, fed in the middle. And I've got coverage on both sides of the Atlantic, and even had a report from the other side of the world in Perth, Australia. And this is a typical data that you get from the database on WhisperNet, hundreds of ground stations worldwide. And I wrote this Python script, which I turned into a Windows executable, so you don't even have to have Python running on your machine to make this work. I have a little text file with all the initialization of your call sign and the flight number and everything. And we just let this run on multiple computers, so if one goes down on one computer, it'll be running on somebody else's. You can have it in different locations. And during a Whisper flight, you can get full coverage transferred to APRS this way. And this is an APRS balloon. I mean, this is a Whisper balloon showing up as an APRS object, both on APRS-FI and tracker.hubhub.org. That's a typo. It should be tracker.hubhub.org, not tracking. So I wanted to talk a little bit about how to connect a magnet wire antenna to a Whisper board. I use fishing line, and I use little pieces of Kapton tape to tape the magnet wire to the fishing line about every foot. And then I use a piece of insulated hookup wire, 26 gauge insulated wire as a strain relief, and then I wrap the magnet wire around the end of an inch or two piece of wire, and then I put Kapton tape over that so that there's no twisting and stressing on the solder joint of the magnet wire. If you put the magnet wire directly on the board, unless you heavily put a lot of Kapton tape on to support it, it'll snap right off. It's got the strength of a human hair, just about. So it's important to strain relief it, whether you put tape on it to hold it. If you just put magnet wire on the board and hope it'll stay there, it's going to come off. So we've gotten a lot of interesting, I love getting young hams involved in Pico ballooning and high altitude ballooning, because this is really the future. One way of getting kids excited about amateur radio. If they can send something to the edge of space or around the world as a mini satellite, you've got them hooked, and they're going to love ham radio and get into it. So this is Jack, KM4ZIA, and he's testing out a Whisper Skytracker by flying at 350 feet up in the air with his drone. So Audrey is his older sister, KM4BUN. They're quite active. They've flown regular Latex flight and long duration Pico flights, and they plan to fly 2 Whisper Skytrackers for GPSL 2020 tomorrow, and they're in the Atlanta, Georgia area. So you see one of their APRS flights. They flew here. Audrey did a Youth on the Air activity where she presented a whole show, about a 35-minute show to the Youth on the Air group of complete steps of how to inflate the balloon, and that she took it out and launched it as part of her presentation. And it was well received, from what I understand, by the Youth on the Air group. So,
Hey, Bill, question here.
yeah.
Has anyone tried the stainless steel conductive thread for an antenna? It's strong and flexible.
I have it, but the resistance of that wire is pretty horrendous per foot. And I have a feeling that I got a spool from Adafruit. It would handle it for sure. It's braided wire, but it's very high resistance, and I have a feeling that it's not going to work too well as a dipole antenna. But I just actually got a spool of that in the mail the other day, and I'm going to try it out in the yard and compare it to a magnet wire antenna and see how well it performs. But it's going to be like 200 ohms for a 17-foot length of wire, and I think that's going to be not so good for an HF antenna. Now, I want to talk that it is possible to get a latex balloon floater. KF4ZTI managed to do this by accident. I recommended that he flew a 2-ounce payload with a little camera, a GoPro knockoff, with one of my Skytrackers with a 4 AAA lithium pack on it. That combination on foam core with, one thing I've been doing, as many of you have seen, is a little piece of foam core I mount the tracker on and the battery pack, and I wrap it with 3 layers of single small cell bubble wrap, and it really is lightweight and it keeps the package warm due to the greenhouse effect. So it works really well during the daytime. But as you look at the chart here, this is a latex floater, 1,200 gram balloon, 2-ounce payload. It went up to 108,000 feet. He only had 2 ounces of positive lift on it. May only have been an ounce. I told him to put about 2 pounds in it, and he put 2 ounces. So it went up to 108,000 feet and floated all day long and then all night long. But the curious thing is, it floated 108,000 feet during the day. It came down to 92,000 feet at night and kind of bounced around over the different terrains. It was going over different mountain ranges in Arkansas, and it was heading west because we're in the stratosphere in the summer. But look at the temperature curve in yellow. So you see the internal temperature was pretty toasty until sunset, where it rapidly drops down to about -50. So bubble wrap does not work well at night. But the batteries, those 4 AAA batteries, lasted all the way up until an hour before sunrise, and then it froze out. But it came back to life as it warmed up and lasted till about 2 in the afternoon, when the balloon finally popped as the UV degraded the latex. It landed west of Harry there in Tulsa. I was copying it here halfway to Tulsa, and he copied it from Tulsa on, and we kind of did a little APRS relay there. And thanks, Harry, for doing that all night. And he organized the chase team that went out after it. They got there just at the 36-hour point where the battery started going, and so they could hear it, but no one had an APRS or direction finding equipment until the guy who arrived later. He got there just as it died. So we know within about a mile where it is, and they let the local landowners know. So maybe it eventually will turn up. I talked briefly about the SBS-13 balloon, which is about 3 foot wide by 7.5 feet long. It's made by Scientific Balloon Solutions, and it's run. I can't tell if you're on here because I only see a few of the names, but Ron Meadows, if you see his video, he's the his son Lee and Ron manufacture this balloon, and they've built a heat press heat sealer that will automatically heat these, and they do great with the new heat sealing process. They're very reliable. You just don't want to put too much lift into them or they'll pop, just like the Mylars is the same way. 3 grams is about the max for a Mylar, and about 8 grams or so is the free lift max on these. And that's what it looks like launching a SBS-13 balloon with a payload. And my first attempt with that, well, I had a couple of first attempts. One had a hole in it because I didn't see the big forklift hole in the shipping box, and it had actually poked through the balloon, and it landed 2 miles away, and we found it through direction finding and listened to the max signal, because we knew it was alive and what grid square it was in, because we were getting reception reports from Texas and the East Coast from 1,000 miles away. And when we found it, it was hanging from a fence post 2 feet off the ground with the solar panel straight up. And I flew it again, and it went around the world 6.5 times for 75 days. Finally hit a big thunderstorm in the Ivory Coast. And if you want to get it back, I'll give you the coordinates, but you might be risking your life. It's in the jungle of the Ivory Coast. Uh, recent flight, KK6BJ-11 went around the world 2.5 times. And he was running an APRS board on SBS 13 and flying beautifully. And all of a sudden, it suddenly came down as it headed across Crimea, which is, you've heard that in the news. It was Russia annexed it from the Ukraine. So, and there's a Russian air base very close to where it finally came down. So did they shoot it down, target practice? I'll leave it up to you. There was no
Failure at
weather.
about time.
There was no weather that we could see, so I don't know. It just seemed odd that all of a sudden it came down very close to that area. But it's nothing but flat farmland, so we may eventually um, get an email from Russia on this one. I want to talk about W5KUB. I got him excited about doing balloon flights, and so he took the YO3 ICT tracker, added a super cap and solar panels. The tracker, the one thing about the ICT tracker, it's small, weighs 2 grams or so, but it has no output filter, no voltage regulator. So he added that to it and put a, that's a 3.6-150 power film solar. It's like my 2 panels I fly on mine, only this is all combined into one. And they use soda straws to support the string and stiffen up the panels. So those are 3 soda straws glued and taped underneath there. And of course, he used magnet wire, and the ICT tracker you can see poking out on the left side of the board, the solar panel. He did a flight. He's been up over 50 days now. There's the launch of the SBS 13 with hydrogen. This is his 10th flight. He flew into a rainstorm on his first launch, and it came down 10 miles away, and it was found by the backup recovery system, the reward sign. And he claims there's a Sky Ant crew, and this is his Sky Ants piloting his balloon. It's been around the world almost 3 times. In fact, today it might be getting close to it. I haven't checked it today, but it decided to go up almost to the North Pole, and then it's coming back down across Canada today. I think it might be over Saskatchewan today. He did an earlier flight where he tried to put 2 power film cells facing horizontally so that he could get a lower sun angle. This was on a, I believe this is on a Mylar balloon, a foil balloon. And it came down in Poland, 1 mile from the sea, near a resort town. And we contacted my friends in Poland, and they went out and got it. It was 100 feet up in the tree. The SP2KMH Radio Club team, they shot a cannon with, oh, actually it wasn't a cannon, it was a, wasn't a slingshot, it was a crossbow. They fired a crossbow fishing line and actually pulled it out of the tree. It was 100 feet up, and they managed to bring it back, and they plan to relaunch it again this fall and make a balloon relay out of it because the payload's still functioning. So we had a flight where they overinflated the balloon from Mount Carmel High School, W6SUN, and it landed, the balloon popped because they had way too much lift in it. It landed 100 miles away in the Mojave Desert, and my friend Mark, W6MAF, went out in a Jeep, and it's a 2x3 or a 3x5 mile search area. I think it's about 3x4 mile search area for a 4-digit grid square. And we were getting signal reports from 1,000 miles away on Whisper quite reliably every day. And so he went out in the Jeep, and all he did was listen for the strongest signal during the Whisper transmissions because there was no other way to DF it for him. And all of a sudden it got really, really strong. And he stopped and he saw that out in front windshield of the Jeep. And that's an SBS 13 laying flat on the desert floor. The antenna was flat on the desert floor and getting out 1,000 miles in each direction every day. And then he decided to trace the antenna wire back to see where the Skytracker was, the whisper board. And it was underneath his front tire. Fortunately, it just banged up one of the solar panels. He didn't run over the board itself, but you can see the tire treads on the left. So with that, I'll stand by for any questions. I'll bring up the chat room and see if there's anything in the chat room here. But I will, okay, Northwest Territory. So it's still looping around in circles over, over Alaska and the Northwest Territories. All it has to do is get to Memphis to complete its third lap, but it may be a while at this rate. I will try that conductive thread in the next week or two and see if it's functional, because then you wouldn't need the fishing line, because that thread's super strong. All right, I'll turn it back to Mark.
Oh, Bill, one quick question in the chat
Yeah.
about how much the SBS 13s cost.
Is Ron on with us today? They're $150+
Yeah, I saw him on earlier, but he's not on now.
Okay.
I just had a question. Where do you get that film for the Mylar, the SBS balloons? I mean, I think it's a special film, right?
It's a special film, and they use it in food processing. It's made in Japan by Gunzi Plastic. Unfortunately, at least in the United States, it's almost impossible to come by because you have to order like 1,000-pound roll of it.
Yes.
Yeah, it's unobtainium.
It's not easy to purchase a small roll of it, unless you live in Japan, where it's easy to come by.
Yeah, I'm in the United Kingdom, and I was trying to get some of that film. And yes, the minimum order is 1 ton of that film, right? A multi-layer film.
That's right. That's right. It's Heptax.
Yeah.
And made by Gunzi Plastic. But yeah, it's hard to get unless you happen to have a food processing plant.
I looked a couple years ago and did find somebody in the U.S. that would supply it, but the minimum was 3,000 to 5,000 feet.
And there used to be a company that sold it by 100-foot lengths. And they also sold those valves that go in the Mylar balloons, the little flat valves. They had all kinds of stuff, and they stopped operating. I guess they sold out of their material.
I mean, how do you think a 3-foot by 8-foot Mylar balloon would do if you could find one?
Well, you can make your own. Mike, SA6BSS, he built his own 3-foot by 7-foot cylinder balloon out of the same material that this balloon back here is made out of. There is a place in the United States called Fluffy Crafts, I think it's called. I'll have to look it up, but she would sell this Mylar balloon material by the 20 or 30-foot lengths, big rolls of it. And he used just a simple clothing iron, because only one side of it is heat sealable. And so he cut out 2 cylinder lengths, and he made his own balloon about the same size of an SBS 13 out of this Mylar material. And he's gone around the world a couple of times or so with them and had good success.
Yeah, I worked with a high school that bought, in fact, I split a roll of Mylar with that high school, and they were using, craft iron to try to seal it. And they launched 4 or 5 large SBS-sized envelopes made out of that Mylar, and every one of them leaked. So you really need some craftsmanship to make those, I think.
Well, Mike in Sweden, he does a great job on his because he's had, of course, he pressure tests them before he flies them. And there is a Chinese balloon that the E3KCL has been flying. They're $1 or $2 a piece, and they have a filling port on one end, and it doesn't have a valve in it. You have to heat seal it. And the other end is another, what looks like a filling port, but it's designed to tie onto stuff. And he's had those stay up. He's got one up since May, flying around the world about 36,000 feet. And they work well, but their quality assurance is not the best. And the odd thing about them is that, so if you get a batch of 10, you might find 2 or 3 good ones. He pressure tests them before he flies, make sure they don't have links, and he can touch them up with a sealing iron. But if you just leave it in the house, it'll lose 2 grams a day.
Yes,
But if you send it up to altitude, it works fine. Has something to do with the humidity causing the permeability to increase. Is the nearest thing that Dave could think of. They just had a little chat in the Pico balloon chat room the other day about that. But those are an interesting alternative. They're $1. You'll probably go about the same altitude as one of these back here. These are about $4 a piece from balloonsfast.com. I have to be careful what batch number you get. If it says 2017-04, they probably aren't going to work because they removed a layer of the balloon or did something to lighten it up. And I only had 25% success rate of achieving float with those. They weigh 33 grams on the 2017 vintage, but the ones that work are 38 grams. So they removed about 5 grams worth of stuff. But this latest batch, they're now 38 grams again. The 2018 batch work well again. And I think they tried to probably cheapen it up and decided they better go back to their original way of doing things. You can get these in different colors, by the way. You can get them in red, gold, blue, and red, and white. White would probably work the best, but the white ones are really hard to find. I do have one. I haven't tried it yet, but the silver works the best for not absorbing, you know, the gold absorbs a lot of solar heating. It goes higher, but it'll eventually pop. The red absorbs way too much heat and it'll probably pop on your first day. But we found the silver one seemed to work the best, but if you can find a white one, that'd probably be the ideal one. Or clear. You can actually remove the silver mylar, the silver coating, the aluminum coating, by scrubbing it with a sponge, and it'll come off. And some people have done that and achieved a little longer flight.
Okay, we should probably wrap this session up. We're about 15 minutes over.
Okay.
But thank you, Bill. That was awesome.
Sure thing. I'll post that video of the balloon race for those who haven't seen it that we did at Dayton last year. It's pretty interesting because we had an astronaut, possibly the first astronaut to fly a ham radio balloon. He waited till everybody else flew before he wanted to make sure he got it just right. And he's the one that hooked his on an RV and a power line. So I'll post that link now. It's about a 5-minute video, so you can watch that during a break.